So today we will discuss some few questions of Neet exam from organic chemistry part. First question is order of decreasing reactivity toward electrophilic reagent. So attack is of electrophile. It means we have to consider aromatic compounds. So all are aromatic compound: benzene, chlorobenzene, toluene and phenol. This is benzene. This is chlorobenzene, toluene and phenol. So phenyl ring is common in all the compounds. This is common part. So differences of hydrogen, chlorine. Okay. So we have hydrogen, chlorine, then CH3 and OH group attached to the ring. OH group is electron releasing group. CH3 is also electron releasing group, whereas Cl is electron withdrawing group. So reactivity toward electrophile will be increased by the electron releasing group. Now it means option number this most reactive are toluene and phenol, but between these two again this CH3 it is donating electron through hyperconjugation, whereas oxygen OH group is donating electron through resonance. Okay, so these have structures. This is our toluene and it is releasing electron density through inductive or hyperconjugation. So we will consider hyperconjugation here. So no bond resonance like this. Okay, whereas this phenol ring is donating electron through resonance. Moreover, you can consider the type of electron that are being transferred. So here these are sigma electron, whereas these are lone pair, that means non-bonded electrons, and we know that reactivity of non-bonded is more than that of sigma. Sigma bond breakage requires some energy. So dominating factor is resonance. So that's why this is more effective over hyperconjugation. It means it will effectively increase the electron density on benzene ring and thereby will increase the chances of increase the rate of attack of this electrophile. Here it will be fast. So most reactive is your phenol and then toluene, then benzene. So this is the order DBAC. DBAC, this is your third option. Third option is your correct option. Next is stability of carbanion in the following compound. Because this is carbanion, it is an anion, carbon bearing negative charge. So any factor which is stabilizing this charge will tend to, this magnitude should decrease. So this will tend to stabilize. Because the options contain double, triple and single bond, alkene, alkyne and alkane carbanion. So means we have to explain this by using concept of hybridization. It is sp hybridized carbon with 50% as character. This carbon is again, this is sp2 hybridized with 33.3% as character. This carbon is again sp2 hybridized with 33.3% as character, and last carbon is your sp3 hybridized with 25% as character. Now S character, how will you explain this stability using S character? Actually your S character is directly related with the electronegativity. S character is directly related with electronegativity. So more is the electronegative atom, more effectively it will disperse hold the negative charge. Dispersal will be more. Dispersal of negative charge will be more. So because this dispersal decrease of negative charge follow this trend that it is maximum for sp, then sp2 hybridized carbon and then least for sp3 hybridized carbon. Okay, so we have to arrange them in order. It means this sp hybridized carbanion is most stable, so A should be in the beginning. It means your option number 1 cannot be the answer. fourth cannot be the answer. So we left with two options only. It is A and this is second and third option. So A is in the beginning. Okay, now between these two, because both are sp2 hybridized, which one is more stable? This benzene carbanion is more stable due to more delocalization of negative charge, dispersal of negative charge. So A and then B, then C. So this is in option number 3. Next question is the state of hybridization of 2, 3, 5 and 6. Only we have to focus on these carbons only, 2, 3, 5 and 6. So numbering is given here. This is 2, 3, 5 and 6. So one trick I want to share you, that just focus on the carbon of which you want to find the hybridization. Count the number of multiple bond, number of pi bonds it is forming. So it is forming 2 bonds here, 2 pi bonds. So just simply subtract that number with from sp3. Okay, so it will be equal to sp1, that is sp. It means carbon number 2 is sp hybridized. Carbon number 3 as all are single bond, so it will be equal to sp3 minus 0, means it itself will be sp3 hybridized. This carbon is sp3 hybridized. Carbon number 5, as it is attached with 1 pi bond here, so its hybridization is sp3 minus 1. This is equal to sp2 hybridized. Whereas carbon number 6 with this, all the sigma bonds, so again it is sp3 hybridized. So you have to arrange them in that sequence only. So very first it is sp3. It means sp3 cannot be in the beginning. So 3 options: sp, then sp3, and then sp2 and sp3. So option number 2 is correct. Question is, which one has most acidic character? So actually the phenyl, that phenolic hydrogen is most acidic. So here this OH is attached to that carbon which is not a part of benzene ring. It is not a part of benzene ring. Okay, so this cannot be the answer. This cannot be most acidic. Again, this oxygen is attached to this carbon, bonding is with this carbon, and this is not a part of benzene. So it is again not that much acidic. Now we have phenol, because all are alcohols. Alcohols are less acidic than phenol. So this is your correct option, because this oxygen is attached to the carbon which is a part of benzene ring. Whereas this is no doubt it is attached to the carbon of the ring, but this ring is not benzene ring. This is simple cycloalkane. This carbon is sp3 hybridized. This is cycloalkane. So this cannot be the option. Next question is, given are cyclohexanol, then acetic acid, (2,4,6) trinitrophenol and phenol. So out of these 4 we have to arrange them in acidic character, decreasing acidic character. So the difference, cyclohexane. Okay, cyclohexane is sp3 hybridized carbon attached alcohol. So simply we can say these are alcohol. So this should be least acidic. Alcohol, then this is alcohol, this is also alcohol. So this should be least acidic. One should be at the end. This is in option number 1 and 4. So third option, here it should be 1. Third option cannot be the answer. So we left with 1, 2 and 4th option. So out of these 3 options, again this 2, 4, out of third and fourth option compound 2,4,6 trinitro, there are 3 NO2 groups. So NO2 group is electron withdrawing group, so will increase the acidic character of phenol, whereas phenol contain no group, so comparatively 3 will be stronger acid than 4. So 3, 4, this should be the trend. So 3, 4, this is in option number 1 as well as in option number 4. So 3, 4 is also there in option number. So we have to compare it with 2. So comparatively acetic acid and 2,4,6 trinitrophenol, due to presence of 3 nitro group, 3 becomes stronger acid than acetic acid. So 3 is stronger than 2. So 3 Yes, and then 2 and 3, between 2 and 4, phenol and acetic acid. Acetic acid is stronger acid. 2 should be greater than 4. So option number 2 is correct option. Others are wrong. 14th question. Among the following 4 compounds, acidity order. So this is phenol, this is methyl group here. It can be at ortho para. And then we have meta nitrophenol. Here nitro group is there. Here methyl group, and here para nitrophenol. This is NO2 group. So CH3 being electron releasing in nature decrease the acid character. Nitro group will increase the acid character. Now between meta and para, because resonance effect is dominate or effective at ortho or para position, so here resonance effect is the factor of stabilizing the phenoxide ion formed, but meta position it will stabilize the ion form through inductive effect only. So again R dominates over inductive effect, so that means D is stronger acid than A. Then we have methyl phenol. Methyl, because electron releasing group, it will be less acidic than A. B is less acidic than A, or we can say A is stronger acid than B. So we can arrange D is stronger than A, but A is stronger than B. Okay, so we can arrange them now in final order. Yes, D is greater than, yes, one more order is there between D and C. D is stronger acid than C. Now C and A, between C and A, because it has nitro group but phenol has no such group, so C will be stronger acid than A. So we have D is stronger than C, then we have B is stronger than A is stronger than B, A is stronger than B, then we have C is stronger than A. Okay, so we can arrange them like we have C is stronger than A, and this arrangement can be these can be arranged now in correct order. So D is stronger than C, then C is stronger than A, and A is stronger than B. So this is the correct option. So this is your option number D, C, A, B. This is option number 4th.